Welcome, everyone. I'll pass it over to Nathan. What's new with DORA?
All right, thanks so much, Amanda. And hi, everyone. My name is Nathan. I lead up DORA here within Google Cloud. We're so happy to have all of you here today. And as per usual, I'll talk about some of the new things in DORA. So the first thing that's new, and it's a month old now, so that's still new, is the 2025 DORA report. A couple of quick things about this report that are hopefully pretty obvious as soon as you look at the cover. The first thing is, if you've been following DORA for a while, you'll notice that we changed the name of this report. This is the State of AI-Assisted Software Development. That is the report that we will be shipping this year, our big annual report. Well, of course, we have other research coming as well. More on that in a minute. But we have changed the name of this report to reflect really what we're seeing in the industry and what we're investigating here. Along with that change is a change that has kind of been in the works for the last 2 years or so, but you might not know this, so I'm going to say it explicitly. We have de-acronymed DORA. So when someone asks you, what does DORA stand for? You could say, DORA stands for nothing. But don't say that, because that doesn't sound quite right. We must stand for something. So what I always say is that DORA stands for our tagline, which is get better at getting better, because that's exactly what we want to help teams around the world do. And that's why we have this community as well, so that we can all learn from each other in our journeys of continuous learning and continuous improvement. So 2 quick things there about the report. I guess the other things about the report to know, if you haven't downloaded it yet or started reading it yet, it is 142 pages long. You don't need to read it cover to cover. One recommendation I have, especially if you have a commute, put the report into Notebook LM and ask it to create a podcast for you. And then you can listen to the report on your way to or from work. That can be a lot of fun. But speaking of AI and research that we release regularly, just last week, we released a new piece of research, understanding the builder intent in the AI era. This was some research that was done within Google, although the participants of this research were not Googlers. So we looked at folks in this software development space, and we really wanted to understand, how are you approaching the work that you're doing when using AI? And we identified these 4 different mindsets that you might have. And the reality is that as an individual, you're probably going to have all 4 of these mindsets from time to time. These are completely fluid. It's not that you're ever in exclusively one or the other. But go check that out. You can get to it at that URL. I failed to put a QR code there, so you're just going to have to type. Sorry about that. Or if you go to ondora.dev, in the research section, there's an AI link, and that's where all of our AI research shows up. And with that, I am super excited to introduce our guest for today. So today, we have the privilege of having Dave Snowden and Beth Smith here, who are going to talk to us about how do we think about and manage complexity. And they're going to introduce a lot of the research and thinking and process that they've built into this space. And so without any further ado, I'm going to turn things over to Dave and Beth. Thank you so much for joining us. Oh, sorry, there will be further ado. I apologize. Before I turn it over to Dave and Beth, I just want to remind everyone, today we're having a presentation from Dave and Beth. There will be some time towards the end for Q&A, but we will not be doing the typical sort of lean coffee discussion that we do, the full open discussion with the community. Although Dave has agreed to come back next Thursday on November 6th, to have almost exclusively a lean coffee conversation around these topics. So consider today part 1, and next week will be part 2. That's all the ado I have. So with that, I'll turn things over to Dave and Beth. Thank you again so much for joining us today.
Okay, so let me do a high level thing. I think Beth and I would both prefer this to be part of the conversation. So if I just throw some ideas out and then we take it from there and we can pick up, all right? And Beth can demonstrate some stuff if that's appropriate and so on. So 2 or 3 things up front. First of all, let's just pick up on what you said on the AI front. Our big action research program for next year, which we triggered this year in Brazil and Wales, all right, which is now started actively in Vancouver in January, is to look at the balance between AI-based decision-making and human decision-making. And more specifically, at what decisions AI can make better than humans, but if human beings don't do them for an extended period, they lose the capacity to discriminate and they don't develop higher capacity. Right? So that's something which is quite important, particularly given that the AI bubble is going to burst big time in the next 4 to 5 months. Right? There was research published recently, if you haven't seen it, which basically showed that AI-generated code only really works in greenfield sites. It doesn't work in brownfield sites because it can't have awareness for the consequence on the system as a whole. So what you're seeing is more and more awareness that AI, which I would never call intelligent, by the way, it's artificial inference, all right? Or augmented inference or something like that. Fundamentally, all right, AI is overhyped at the moment. And one of the things we're now recommending to organizations is do not lay people off if you can replace them with AI, but find out what else they're capable of and use that. Because if you find out the AI can't do it better, you can then recover them very quickly. So if anybody's interested, we've now got a product on this which looks at what are people's hobbies, what are their fascinations, what are their first degrees, what are their interests, all the things your employees might know that you've never bothered to use because you recruited them for a single purpose. Yeah. So again, we're just trying to get this balance thing right within the system, right? So that's kind of like one aspect. The other aspect is we move now into complexity theory. So let me do a sort of 101 complex adaptive systems thing. And please don't confuse complexity theory with systems thinking. They have completely different origins and completely different strands. And actually, the origin of the difference you can see in the Macy conferences in the fight between Bateson and Ashby. So Ashby is taking a sort of concept of information based on Shannon, which most people in IT will be familiar with. It's sort of a data signal type concept. Yeah, and that leads to the assumption that human beings are what Andy Clark satirically calls intelligent cameras. Yeah, they receive data and process them through mental models, which, by the way, sorry about this, Nathan, there's no such thing as a mental model. It's a complete nonsense. It's the wrong metaphor completely, all right? Most of our decisions are made by our body or by our social processes, not by our brain anyway, all right? This is distributed cognition. So, sorry. Shouldn't go down these because I'm getting too tempted to make my life difficult for you, right? Fundamentally, what actually happens is we process data in very different ways. What Bateson argues for is the role, for example, of metaphor. Yeah, and the Macy conference splits over that. It's why most of us would say Bateson was an early stage complexity thinker, not an early stage systems thinker, because for human beings, metaphor is information. Yeah. And we think metaphorically, we think through stories, we think through narrative. Right? And art either comes roughly at the same time as the initial development of language or precedes language. So things like drawing and painting turn out to have huge value in human evolution because art creates abstraction, which distances you from the material, so you see novel patterns. One of the reasons human beings can survive in radically changing circumstances is they have the ability to innovate far quicker than other species. And we now know that art is critical to that innovative capacity because it allows us to see novel connections. The downside is it also makes us prone to conspiracy theories. Yeah. So never an upside without a downside, but that's the nature of it. So human beings think abductively, not inductively. Yeah, we make novel, unexpected connections and we act on them very quickly. And again, that's got millions of, thousands of, hundreds of thousands of years of evolution behind it, so it's an advantage. And I'll make this other point. Human beings don't have training data sets. AI does. Part of the thing we originally developed SenseMaker for many years ago when I was working on DARPA is to create epistemically balanced training data sets. And I'll say this now in context of AI use, is that basically training data sets are far more important than the algorithms. At the moment, if you're using ChatGPT, 40% of its input is its own output because of the way it's scraping data. And once models start to feed off their own output, they're getting perverted very quickly. So again, one of the things we do as a business is allow people to create epistemically balanced training data sets, again, based on that concept of abstraction. Now, all of this is recognizing the essential feature of a complex adaptive system is that it is dispositional, it's not causal. There isn't a material linear relationship between cause and effect, but the system has dispositions and it has regularities or propensities. So for example, termites nests, all termites nests are different, but they have a similar pattern. Every snowflake is different, but they all have 6 axes. So dependent on the granularity or the structure, the regularity may create order, or it may not. It may disguise it if you go with more finely grained material. And a lot of people in complexity theory, particularly in IT, forget about regularities. Complexity becomes an excuse for not having to do anything because it's all complex and emergent, so I can just forget about stuff, all right? Which is pathetic, all right? Complexity needs more discipline, not less discipline in terms of the way it works. So one of the ways I've learned to describe this is think about effectively a set of electromagnets arranged in a ring. Some of them I control, some are controlled by people I know, some I've got no idea whether they're controlled, but they're changing. And in the middle of that circle, there are lots of metal objects. Now, if all of the magnets keep the same strength and the same polarity, then the metal objects will form a stable pattern. If I change one magnet, I can predict the results. If I change 2 magnets, I can predict the results. If I change 3 magnets, I can no longer predict the result. Yes, variation of the 3-body problem. I can simulate it, but simulation is not prediction. But if I can control enough of the magnets and I have real-time feedback loops, I can manage the system. Now, I don't have to predict in order to manage if I've got real-time feedback loops. Yeah? And that becomes critical in all sorts of ways. Yeah, and one of the consequences, anybody who's developed legacy software, and I spent far too much of my time in legacy software environments, knows that if you do anything novel, the only thing you can guarantee is unintended consequences somewhere else in the system. And that's another characteristic of a complex adaptive system, is every intervention produces unintended consequences, and you have to be ready for those and take consequences. So a complex adaptive system is inherently dispositional. Yeah, I can actually measure the dispositional state. I can measure when it may be about to go through a phase shift. I can identify the likely areas of development or how it would develop, but I can't produce a predictive model. Yeah? So that's complex adaptive systems. And the Cynefin framework is not actually a complexity framework. It's a framework, it's a decision support framework which uses complexity. It basically says in a complex system, you can't behave the same way that you behave in an ordered system. But there's nothing wrong with order. That, by the way, is the big difference between Cynefin and Stacey. The Stacey matrix says everything is complex and based on human perception. Cynefin says human perception is a factor, but actually real systems exist in reality as well. It's not just down to perception. And order is quite valid in human systems. Give my favorite example. I don't want to know whether driving on the left or the right-hand side of the road is an emergent property of the interactions of the initial drivers every morning. I want some stability, and that's called scaffolding, yeah, which human beings do. Human beings create order for good purpose. If I look at technical debt, I had a simple attitude when I was managing software teams. If anybody did something quickly and said they would refactor it, if they did it 3 times, I fired them because I knew they would never get around to refactoring it. Yeah, a small amount of effort up front is the best way of handling technical debt anyway, right, in terms of the way you work. So complex systems require attention to very small things in the immediate present in order to, it's called anticipatory thinking, in order to reduce the energy cost downstream. Yeah? So that's a bit of a brainstorm on that. I want to talk about two other techniques on this, and then let Beth tell me where I've gone wrong or add to this or whatever, because Beth didn't know she was coming in on this until I called her this morning. So whatever she does is genius as a result, all right? One of the big things we started to do is called S-strand mapping. This comes from constructor theory and quantum mechanics. And what we do is we identify everything in the system which is having some impact on the system with some level of agency. So that could be an actor, it could be a role, it could be a person. It could be a constraint, like a legal framework, or it could be a constructor, like a process or a software object as a constructor. You know, if an input will always produce the same output, so it's a stable element within a complex system. Yeah. So what we do is we identify all of the collective name for all of those is called actants. This comes from actor network theory in Latour. So basically, all actors are actants, but not all actants are actors. So I map all the actors in the system, and I put them on a grid between the energy cost of changing them and the time to change them. And that's all negotiated by a group of people. And there's a simple rule: if you can't agree, break it down until you agree. Because I want an objective assessment of the current situation. I don't want power to intrude. So compromise means the most powerful win. Break it down until you agree gets rid of that problem. And of course, anything top right on that framework, the energy cost and the time to change is so high that realistically it won't change. And that's called a counterfactual. Yeah, that's part of the firm aspect of the system. It isn't going to change. Anything bottom left can, to use an American expression, turn on a dime. So it's very dangerous because it can change quickly without expectation. And the only things you can manage are the things in the center of the space. And the key thing on S-drone mapping, which is what it's called, is once you've mapped that, you then say, how can I change the dispositional state so that things I want cost less energy and things I don't want cost more energy or more time? This is a great 2.5-day process before you even start a software project. Is you map the dispositional state and you change the environment so things are more likely to go in the right direction. And again, that's a classic complexity technique. Focus up on the nature of where you are, not where you would like to be. And so the final conclusion on that, before I hand over for comments, we also call this the Frozen 2 strategy. Anybody seen Frozen 2, the movie, yet? Okay, Frozen 2 is a great complexity movie. And I'm getting quite desperate for Frozen 3 because I want to find out what happens with the parents. So this is a real problem for me at the moment. It's frustrating the hell out of me, right? But either way, in the middle of the Frozen 2, the real heroine of the series, who's the younger sister without the magic, is lost in a state of total despair. And she sings this beautiful song, all I can do is do the next right thing. That's complexity. In complexity, it's called the adjacent possible. And this actually starts to change software architecture. We're now looking at a whole new approach to software architecture in which you define the scaffolding and you define the interactions with monitors, and you allow applications to emerge, and you can have human, and I'll leave this thought with you, there's no reason why a combination of human roles can't be an object in software terms. One of the ways you handle ambiguity in software development is you have a human object to deal with the ambiguity, and you wait for patterns to emerge from that before you further co-define. So we're working very solidly here on human-machine hybrid approaches, using complexity as the underlying theory. Beth, sorry, I'm coming off a hype session with atomic scientists, so it's always dangerous on this. No? Over, do you want to add anything to that? And you're muted.
It was certainly my intention to start with Cynefin 101 on the assumption that not everyone even knows what Cynefin is. So
oh, I'm bored with that.
that's what you bring me along for. You get to talk about the exciting stuff and I can bring it back to basics.
That's the benefits of age, Beth, all right? There are downsides to age, but that's one of the benefits.
Yeah, so just to kind of give people a bit of familiarity, I suppose. So the Cynefin framework itself is a recognition of the different types of characteristics or ontologies of either scenarios or decisions. So this is kind of in its most simple form, clear, which is where we ultimately know all of the variables and we can manage all of the variables in the system. Increasingly, I'm saying, this is the kind of something that falls into this category is something that quite often can be automated. We have complicated, which has variables in it that, the average person on the street might not be able to know and identify, but ultimately somebody out there can. It's what we call the domain of the expert. Chaotic, typically a case where you don't have any kind of real sense of cause and effect or control over things within an environment. And then complexity falls somewhere in between the two. So there is a sense of patterns. You will see dispositions, as Dave mentioned, but ultimately there's always going to be unknowns within that kind of environment. And I think, I'll give you a bit more reading and we can go into this in a bit more depth. But I think one of the key issues that I find with people applying this as a framework for the first time It's just because a problem or a scenario is complex, is to assume that everything within that must also then be complex. So in terms of how this can become a really practical and useful tool for people to use, particularly within a kind of a development environment, is to think about an issue, a scenario or task that you've got to do, break it down into smaller parts and see which of the discrete items fall within which domain, because each of the domains come with a different set of management principles ultimately. And I also have what I call the Cynefin for dummies, which is a much easier way to remember this. So in the clear domain, you've got the, well, duh, it's obvious. It's an if A, then B. You know, this is the domain of the decision tree. We look at what's there, we put it in the right category, and we respond according to the rules, usually from best practice in previous cases. This is like the recipe book. You know, this is the best way to build a Big Mac because there is an absolute, you know, recipe and agreed way of doing so. The complicated domain, however, is the hard domain, whereby, you know, as I say, you won't necessarily be able to identify cause and effect or as a person on the street. But thankfully, someone out there knows this domain well enough to know where to look to ultimately find the right answer. I always say you can, you know, building an aeroplane, you would never trust an aeroplane that I've built, but thankfully there are people out there who know what they're doing. The chaotic domain, the WTF domain. This is typically where all of your previous ways of working, your kind of recipes and habits and structures either fall away or suddenly become no longer useful and relevant. So something like a digital blackout, a natural disaster, you know, suddenly everything's fallen away. So the initial response to that is just to do something. The main goal is to get out of chaos. Usually a temporary state. And then, as we say, we've got the complex domain, which is the domain. So there's something going on here. I'm not quite sure of what it is. You know, we're seeing patterns and we can have a sense of what's going on, but we don't fully know what's going on. And as David mentioned, the only thing that we do know is whatever we do is likely to have unintended consequences. And so the really helpful way of understanding and distinguishing between complicated and complex is to look at the word root. So to be complicated comes from the origin to be folded. So anything that can be folded can be unfolded and refolded in exactly the same way. Whereas complex comes from this idea of being entwined or embraided. And I don't know, I always use the metaphor of a ball of wool. You know, if you untangle a ball of wool, you can never quite retangle it exactly how it was before. And whichever bits of the wool you pull on, you don't fully know what else it's actually attached to or pulling on or causing tension on. And ultimately, I suppose my key takeaway or piece of insight for you to consider here is what I call domain dissonance. So when you're dealing with an issue or a decision, to reflect, you know, which of the domains does this particular issue fall into? And are my, you know, principles of action actually coherent with the domain that I'm in? Because you will notice at the bottom between chaotic and clear, there's a little extra squiggle, which I often call the cliff of complacency, which is typically if you treat a complex problem like it's clear, it very soon becomes a chaotic problem, because there are all kinds of things that go ultimately unmitigated. And so just to give you kind of one last little kind of visual representation, I like to define the difference between a complex and a complicated system as the difference between salad and bread. So a fruit salad, you know, you can chop it up, you can put all the things in there together. Ultimately, you can pick each one thing back out. But with bread, the ingredients go in and they come out having experienced emergence, so entirely new properties form on the basis of the interactions of the individual ingredients. And you can't unbread bread once you've baked it. And so actually what we look at often when we're looking at kind of socio-technical systems, there's a lot of, people will be looking at the algorithms, the decisions happening on the computer. But, how often is it that the problem or the influencing factor is actually between the screen and the chair? And we start to recognize that, between behaviors of people, interactions of computers, entirely different and new emergent behaviors ultimately are created. And, particularly when we look at things like organizational culture and the likes, these are things that don't have any single origin, any single root cause. And so they're best understood using complexity approaches, namely looking beyond just quantitative measures and starting to understand context and stories. So I'm going to stop there so we've got time for discussion.